So we're going to talk a little bit today about understanding what your company is buying from the co-op. So that's one of the energy management basic understanding principles that sometimes gets lost in the shuffle when management's used to coming to you, the technical side of the operation, and saying, well, can't we buy something new that's more efficient and will save money on our bill? That's a very good energy management strategy. Take out old things that are inefficient, that don't operate well, if there's new technology replacing it, and attack your energy bill that way. I find a lot of companies go past some of the first steps and don't look at that bill enough over time to understand if they're on the right rate or they could be on a lower rate, to understand what the line items and the jargon that goes with those line items mean, and how those numbers are calculated and how they impact how much money your company pays then for electricity. So your electric rate structure is available from your power supplier. They have a document that's going to go through and tell, for your rate class you're on, what all of those terms mean, the line items on the bill, and all those line items will add up to that total, okay, what do you have to cut the check for? The reps can explain the information and structure so you understand that jargon and how those calculations are done. And so sometimes understanding, even for me, working with utilities all over the country, the calculations from one utility in one state to another for the same thing are completely different. How many of you go to a store and buy something without knowing what the price is? Most people don't operate that way. How many of us buy electricity for our facility or use electricity, and then the bill comes, we just pay it? And we don't understand what that bill is telling us that we might be able to manage better. So that's what we're going to talk about. It serves as a great first source for data for analysis in terms of any energy management program or effort. So what do you pay for? That idea of knowing what it cost me. If I don't know what it cost me when I do certain things or turn certain things on, it's hard to manage then my overall costs in a facility. So there's a number of typical line items you will find on that electric bill. No matter where you go, what utility, the names might change a little of what they call them, but it's a general same premise. So there'll be a customer charge or service charge. That's a fixed fee per month regardless if you turn any electricity on or not. You can't do anything to change that. So that's not manageable. The energy charge and the fuel cost adjustment, or as Hoosier and the co-ops here call it, the power cost tracker. These are line items, if you look at my example bill, that are based on the number of kilowatt hours of energy used by your company during that last billing period. So if I make kilowatt hour use, energy use go down over the billing period, both of those line items out here get smaller. And anytime I make one of those line items get smaller, that's a good thing in terms of the total. Demand charges are based on your peak power use during the month, your kilowatts. And we'll talk about that more. And so keeping that down can also have an impact on lowering that demand charge line item. Power factor adjustment, as I've been observing things in my 35-year career so far, is becoming more and more important for more utilities and their customers all the time. We'll talk more about that in detail today, but what your operating power factor is at your plant today can have a pretty significant impact on what you're paying overall for electricity. So a power factor adjustment will be given on your co-op or Hoosier bill as a line item. And so that's something that you can manage in your facility. And then governments, be they city, county, or state, like to use the co-ops and power suppliers as tax collectors. So there's probably going to be some taxes and other assessments down at the bottom of the bill. And most of you understand that taxes are typically a percentage of what the cost is. Now think about that. in terms of overall energy management from a strategy, and just being able to relay why we're doing some of these things, maybe to the business people that ask you questions. If I make some of these line items on the bill above go down, what happens if my taxes were based on a percentage of all those things above it? They go down, don't they? So I get that cumulative effect in terms of, if I manage these individual line items, that makes my bill go down, and because the taxes and other assessments are a percentage, that makes that line item go down as well. So that's the strategy from the big picture I like to put in people's mind to say, okay, why do I care about those individual lines? Because those can be targeted in your facility to say, what are we doing now? What are we paying now? And what are the things we can do to make that number go down and pay less overall? What can we manage? I've seen as strange things on utility bills as hospital district taxes. How would a hospital district tax get on an electric bill? The county says to the utility, you don't have a choice, you collect it. Why do states and counties, cities like utilities as tax collectors? They're sending a bill out to that property every month, right? And who's the bad person? Not this county when you see it on the electric bill, right? Ah, okay. So those are those types of things that we can, complain about and, grouse about, but essentially that becomes important to understand. I've seen some taxes and other assessments at certain places in the country where that could be 20% total of the line items above. And that becomes a pretty big chunk of what you're paying then in terms of going then to the utility and they're passing it through to the government. So evaluate those line items. Energy management basics. Are there energy reduction possibilities? And so those are things that Hoosier and the co-ops have talked to you about for a long time in terms of energy reduction. What energy management strategies? Energy efficiency programs. Can you use, the folks here in Indiana that they've had on the program before to do energy audits? Bring them in to your facility. Analysis, all kinds of stuff. So if your energy use or kilowatt hours goes down, your power cost tracker line item will go down as well, because that power cost tracker is basically used by the co-ops to make fuel adjustments in fuel costs from month to month. So when the co-op makes their rate, they're usually making that rate going forward. This is the rate we're going to charge you into the short-term future based on what we looked in our crystal ball and said our costs are going to be. So they implement that rate. Now, what happens to Hoosier's fuel prices on a daily, weekly, or monthly basis? Fuel is really volatile. And so they looked in their crystal ball and said, we think it's going to do this, we'll set the rate there. What happens if Hoosier's fuel prices go up above what they estimated? They're not collecting enough money to cover their costs. So it used to be that utilities would wait a year or two, and then they kept track of how much money the customers owed them for fuel that they purchased but wasn't in the rate, and then they jacked their rate up to cover that. And people complained. So most utilities today have a monthly varying power cost adjustment or tracker there that essentially does that on a monthly basis, so they can keep more current. It could be a credit or a debit. Demand reduction control possibilities. There's all kinds of active demand management and control strategies people use today. Some of those are just to train the employees, if this piece of equipment is running, you never turn this piece of equipment or line over here on simultaneously, because it'll set a great big peak demand. We don't want to pay for that. If I have a standard operating procedure I've written down, can people still screw up? Potentially. So some companies will go to demand lockouts. actual devices, mechanical devices, electronic devices, where if this piece of equipment is on, they can hit the start button on this one over here, or this line, and it will not come on if this piece of equipment is on. So I take the oops out of the employee's hands by putting a device there that says it's not happening unless you bypass the device. Okay, power factor improvement. Increasing power factor to reduce billing demand on your bill today can be a very, very good strategy from a cost-benefit ratio. So that becomes important. Taxes, I mentioned that. What happens when you reduce any of the line items above? Those go down. Now, important part that the Hoosier and Co-op folks wanted me to emphasize here is your company sales tax exempt? So many manufacturing companies in many states are sales tax exempt for the electricity they use in making whatever you're making, your product. The office electricity use may not be exempt from sales tax, but the manufacturing electricity is. So if you do not have a sales tax exemption and you think you might qualify for it, there's paperwork to do. Do you qualify, and do you know if you qualify, or do you know if you've done the paperwork, somebody at your company? See your key account rep. They can help walk you through that process to make sure then that things are like they should be and you're not getting charged sales tax for your manufacturing electricity if you're exempt or could be exempt. Very important in terms of those things. So that energy use and power cost tracker. Okay, we talked about those things. The rate paid for the energy kilowatt hours used by the customer during the billing period. Energy rates can be various different structures out there. They can be a flat rate where every kilowatt hour you buy for the month is priced the same. Some utilities like that, some customers like that because it's easy to remember. I don't have to remember if there's a time of the day after that the electricity gets cheaper. Or there's a time of day in the morning where after that it gets more expensive. Or if it's more expensive in the summer and less expensive in the spring. So a flat rate is easy, but it doesn't give us a price signal. So some utilities use energy rates then that are seasonal or time of day, where the price can change during the day. And so that could be an option for your company if your co-op has a different rate structure that they can put you on, where the price might change. I've seen a lot of companies that go on a time of day rate or time of use, and they move a lot of their heavy electrical use equipment out of the afternoon till later in the evening when the price of electricity gets real cheap. I have to have some more people in later in the day in the plant, but simply by moving when you turn that equipment on, if you have an option there with a cheaper rate at a cheaper time of day, you save money without buying any new equipment. Okay, so nothing to say to management, we need a budget to buy this new piece of equipment and put it in to save money. We're just changing the time of the operation to save money on our power bill. So those becoming close. Notice my customer used here in my example bill 397,500 kilowatt hours last month. Okay? We take that times the rate in the energy charge line of 7.5 cents, we get the dollar amount. The power cost tracker here was 0.0031 per kilowatt hour, cents. We take that times the 397,500 kilowatt hours, and we have that line item relatively going to that extra fuel cost that the utility had to buy fuel that last month above the price that they estimated for the 7.5 cent rate. Okay, so that's how those are calculated typically. My kilowatt hours of use times the rate, that gives me the line item out here. So that becomes important. Now the demand charge is something that I have as a consultant have helped customers with ever since I started out in the industry. So a lot of customers don't understand why the utility would bill them for their one-time maximum peak power use every month. It's really a way to allocate the cost of excess capacity in the electric grid to the customers that cause the need for that excess capacity. So notice in my example, I have a demand charge and my rate is $10 per kilowatt. So I take that $10 per kilowatt times the peak demand that customer set in the last billing period. In my example, that customer's peak demand for this billing period was 879 kilowatts. So they have a meter that keeps track of that, what the maximum demand is. So I take the $10 times the 879 kilowatts, we've got $8,790 as a line item for demand. Think of it this way, if I'm trying to explain. On that day that we set a demand of 879 kilowatts of equipment all running at the same time, what would have happened if there was 50 kilowatts of equipment that really didn't need to be on, but somebody was just too lazy to turn it off? What's the impact of that extra 50 kilowatts that was running times $10? $500 for the month on the bill.
So my question is, that demand charge would be the same no matter if you were on the time of day billing? Is that correct?
Correct. Correct. So this is completely separate than energy. Okay? And that's always what I like to tell people when they're explaining to people. Notice these are kilowatt hours and that's energy, the meter tracked over the month, and demand now is kilowatts, and that's completely different. Okay? And it goes back to understanding what you pay for. What happens there? I work with some clients who manage that very aggressively. We'll see a slide later. You can tie some of these interlock things to your energy management system. If you have an EMS system in your plant, you can start setting budgeted trigger levels. So I have customers that say, we do the same thing pretty much every day, and we are going to essentially manage this, and we are going to say that that's our normal level, that's the maximum we're going to pay for. And we're not going to let an employee have an oops for their own convenience to run more equipment at our peak time than we really need to operate. So typically what will happen in the old days, when they got to 80% of that number, the energy management system sent a signal to physical plants' pagers. And that signal was basically, when they checked, this is a stage 1 demand warning. We're at 80% of the maximum we want to pay for, ever. So what happens? They start looking around and saying, are there things that we can shut off that we don't need right now? The people have left on. When it gets to 90% of that value, used to be pagers, now the physical plant people get a text from the energy management system. We're at 90% of our budgeted maximum. We're at stage 2. If it's not making money, turn it off. And when they get to 95% of that budgeted value, they actually start turning things off they know that they can turn off. It might not be optimum, but they are not going to go over that number, because that blows their energy budget when they do that. So people have looked and said, okay, if I'm not managing that, and think about it this way, explaining it to your business types. If you are not doing anything to manage that, is your strategy trial and error? What sets your peak demand? Whatever the folks in the plant decide they want to turn on for their convenience on a heavy use day. At some point when you start managing energy, does it make sense to start taking that option away from employees to turn on anything and everything and leave it on even when they go on break, because it's just easier to come back if the equipment's on and start up again after break? And so those are the types of things we're looking at today. And so in many instances, just coming up with an education plan for employees that says you can't run this and this at the same time can save you a bunch of money on that line item in the bill without having to go out and buy new equipment. Or if you have the energy management system, now utilizing it to warn you to say, okay, now we make an announcement. If it's not important, shut it off right now for the next half hour to get through the peak, because then we'll be done with the big energy use equipment. Our demand will start going back down today, then we can turn it on.
This is based on plant demand, correct?
Yes.
What about local demand?
As in the town or the area?
Yes.
Now the question becomes, in the jargon they use in their rates, was that your peak demand at your maximum time, or is that number taken from the co-op's peak? And so the jargon terms we would use in the industry there are coincident peak or non-coincident peak. If I'm billed on coincident peak demand, that means that number came from the amount my plant had on at the time the co-op peak happened, or Hoosier peak. If it's non-coincident peak they're billing on, it's your plant maximum. So in terms of the rules, you see how the rules and the jargon becomes important? Is it important, do you know, if you're billed on coincident or non-coincident peak? Very much so. Okay?
If you're billed on coincidence, then how are you supposed to know when the local peak is?
And now you start talking to your account reps. And your account reps have a very good idea in what drives that coincident peak. I was telling them last night, in my market in Texas, we're deregulated. I have friends that do a forecast every day, 6 o'clock in the morning. And at 7 o'clock, they send out a text to all their clients, commercial and industrial customers who are paying for that service, to say whether today is going to be a coincident peak day for the power supplier or not. So they pay money to find that information. If it looks like it is at noon, every 15 minutes, my friend is updating his forecast. And all of a sudden, if the load starts breaking over, it rains in a big area and the load goes down, then he says, okay, it's not going to peak today. What you were planning to manage from 3 o'clock till 6 o'clock, shut stuff down, don't worry about it. So, good question. You need some information and data. So having a source where you can talk to your key account rep or your co-op folks, many of them have programs that can, if you're on coincident peak, alert you earlier in the day, or at least an hour or 2 hours ahead. It looks like this is going to be the peak, and give you that feedback information so you can decide what you want to do that day.
All right, so what I just heard was this demand charge, based on this gentleman's question, could be determined by factors that are out of our plant's control. Is that what I just heard in the layman's term?
The actual number of when that number is taken off of what you used. So you still have the control if you know that that day is going to be a co-op peak day to decide what you want to do. Now, let's go to the other side of the coin. It used to be that most utilities did what they call an interruptible program. You signed up for a contract that said, on a peak day, you will shut off your plant or reduce a megawatt. And when that peak day came, what did Murphy's Law say about the day of the year, the only day, the worst day for you to shut down? Was the day of the co-op peak. And you said, well, what if my sister plant over here in Indianapolis shuts down because we need to run today? And the attorney said, no, we have a contract. You signed the contract. The contract clearly states the penalty for not shutting down is X dollars. And so people said, yeah, we like the interruptible until we don't, the contract. So the coincident peak is more of a, okay, instead of having a contract where you agreed to a lower rate to shut down, and there's a penalty if you don't, we're going to give you the option to make that decision. We're going to tell you what's going to drive that peak. What the number that we're going to pick is when the co-op peaks. And now you have the option, if we get that information to you fast enough, to decide what you want to do about it. Is this a day where you absolutely have to be running because you have finance people in from Wall Street looking at your operation and management says there's no way in the world we're shutting down? Or is this a day that it really doesn't matter and we can either drop a bunch of load or shut down? So we're looking for how do we give you more control to make that decision instead of a contract type of thing that's predictable. So that's the idea. Account managers.
Jump in to clarify, there's only a couple customers in the room that are billed on coincident peak, where you're billed from the system piece. The majority of the customers in this room are on what we call NCP or non-coincident peak, which is just your individual peak. So there's a couple exceptions in the room, and you probably know who you are, but if, when he's talking about this, the majority of the people, it's your personal peak. It doesn't have anything else to do with what's going on in the system. It's the majority.
I don't always agree with every utility principle, the way they come up with things. Whether you agree with it or not, is it important that you understand that at your facility? Which one of them you're on? If you're going to manage that peak, it's very important that you understand essentially what somebody at your plant signed up for in a contract, or the rate that somebody previously to you decided you were going to be on. And then the question becomes, okay, if you are on coincident peak and you aren't sure that it's the best thing for your plant, do they have another rate they can put me on that's different that we think works out better?
Is that a change that would ever be proposed to us to go to coincidental charge?
Yeah, when your local co-op starts looking at rates and they start doing their cost to service study, I mean, a portion of the bill they pay to Hoosier Energy's on both, and they would definitely look at that. At each co-op, the rates are a little different, and your ability to switch between this rate and that rate are different. So it's just something we follow up on and see if there's something else going on.
As long as we wouldn't get changed without.
In my experience, a co-op is always going to give you lots of warning and education in terms of doing that would be considered a very, from my perspective, working in the industry my whole career, a very, very drastic shift to go from non-coincident to coincident peak billing. And a co-op board of directors is really going to have to struggle with that type of question, as opposed to maybe a public utility where people don't have such a vested interest in the local area. Okay, so, but the message I really want, and good questions, great questions, very important questions. If you are going to manage this, you really need to know what those numbers mean on your rate in your facility. How do they get that number? And based on the rule of how they get that number, even if we don't like it necessarily, then once I know how they get that number, I can figure out how to manage it for my company's benefit. What I can do, what I can't do, what will work. And the good point here, because each co-op's rates are slightly different in terms of the structure, just because one of your sister plants did something doesn't mean that it will work to lower your demand at your plant if you're served by a different power supplier, because the rates and the rules change from one to another. So those become important things in this, okay, saving money, energy management in terms of the bills and things like that. Now, some demand rates have ratchets, and that adds a complexity as well. Now let's talk about why a demand charge. Many of you essentially understand this at some level based on products that your company makes and conversations you've had with your economic and financial money folks at your facility. I have two different customers, customer A and customer B. Customer A is the blue line, customer B is the red line. Customer A runs 3 8-hour shifts, 24 hours a day, 7 days a week. Last month their consumption was 75,000 kilowatt hours. Customer B is different. They only have 1 8-hour shift, 7 days a week. But they have some large energy intensive equipment they turn on to make their widgets. They also used 75,000 kilowatt hours last month. So here's B with their big energy intensive equipment. After lunch, they hit a peak of 500 kilowatts. A, running 24 hours a day, is always around 100. Now that's a little theoretical there. I didn't make it go up or down at all, but I just wanted to illustrate two very different customers in terms of how they use power during the day, but they still use at the end of the month the same energy use, kilowatt hours. So think about the equipment coming from your co-op into your facility, the stuff the co-op had to buy and put out there. If we charge them only for energy and not for a demand difference here, those two customers would pay the co-op the same revenue, same rate. If those two customers were paying the same dollar amount to the co-op because they use the same energy amount, which customer is subsidizing which customer?
He's subsidizing B.
Why is A subsidizing B? What are some of the things that the co-op had to spend more money in to serve B than A? Biggest one there probably is the size of the transformer. Does the size of the conductor have to be bigger? Yeah, I got 5 times as much power I got to carry into that facility for B than A. And so that becomes, okay, oh now I see where we're going with this. Customer B has 5 times as big a transformer, it probably costs 5 times as much. So if we bill them on energy use, we don't essentially take that difference into account between those two customers. So the demand charge is meant to charge some of those costs to that customer that creates those costs for the utility in the system. How about generation plants? How much generation does the co-op have to have, or Hoosier have to have, for B compared to A? Now, that costs money to build a generation plant. Customer A is using that generation capacity 24 hours a day. Customer B is not. Customer B says, well, I kind of see where you're going at, but if I'm not using it, sell it to somebody else. What's the problem with the utility that invested money in that plant trying to sell that extra 400 here or extra almost 500 at 3 o'clock in the morning? Nobody wants it. There's no demand for it. So that 500 kW, a lot of it sitting there idle all day long, but the co-op still has to pay for it. And the transformer's bigger, and the wire service drops are bigger, and the other equipment's bigger. So the demand charge is meant to be, how do we essentially allocate those excess costs that B puts on the system to customer B instead of socializing it over everybody? That's the idea. And now what they've done is they've given you a price signal by putting a demand charge on the bill that says, manage it. You want to make it go down, figure out how to make it go down in your plant. Now what really makes it more complex is if you have a demand ratchet on your demand charge. So this adjusts for large changes in demand throughout the year. Your monthly demand charge minimum is determined by 1% of the previous 12 months maximum. So if you are ratcheted, your demand is ratcheted, you might in 1 month have to pay based on the previous 12 months peak, your last year's peak previous, instead of what you peaked this year. And so, as an example, I used an 80% ratchet. So, in an 80% ratchet, it's easier to go through example here than think about that definition. I owe this month what I set for peak demand unless 80% of my previous 12 months peak is higher. And so now this is really a price signal that says manage demand not just on the peak days, but throughout the year, over time, if you have one of these. Does anybody know if their demand is ratcheted here in the room? Is that something important you want to know if you're thinking about managing power? Yeah. So as an example, let's say my previous 12-month peak was 200 kilowatts. Okay? So January I was 200. I didn't put back, we're going to talk about July and August. I didn't go 12 months. My chart was already getting big. But let's just say January was the previous 12 months peak at 200. So 80% of 200 means I pay for, after I set the 200 kW peak, for the next 12 months, the minimum I must pay for is 160. Even if I don't use 160. So notice in July. In July, my peak demand was 190 for the month. 190 is more than 160, the ratchet, so I pay for the 190 in July. So if current peak is more than the ratchet I calculated, I pay the current. Now in August, the plant had a shutdown. They were retooling, going through equipment. And so in August, this plant only peaked at 120 kW. In August now, we say, okay, I peaked at 120, but 80% of my previous 12 months peak was 160, so that plant pays for the 160. We really, most of us don't want to be on a ratcheted demand rate. But it does give you another tool to manage cost on your electric bill over time. Give you an example. I worked with a customer in South Texas a number of years ago. And they had a facility, and they had a great big dirt lot that they brought product onto as an input to their facility while they were waiting to essentially get to it. And one day the wind was blowing, and this was an old facility that was close to downtown, and the dirt was blowing off the lot down into the businesses on Main Street. And at coffee that morning, down at the coffee shop, the businesses told the plant guy who was there, said, we're really tired of your dirt blowing into our businesses when the wind blows. Can't you do something about it? He said, oh, I didn't realize that. I'm terribly sorry. I will take care of it. So he went back and he had employees hook up a great big hose, 3-inch hose, to a big pump. And they went out, and while the plant was running, this pump had never run while the plant was running. It was a different type of an emergency system. Watered down that dirt lot. Took them about 40 minutes to get all the dirt down, essentially cover the whole thing. That was about 100 kW pump. They were on 100% ratchet. Over the next 12 months, going 100 kW more than they had ever gone before cost them $37,000 over the next 12 months to water down that lot for 40 minutes. Oops. Is that important to know if that's how the rate is that you're being billed on for whatever reason? So again, the message is, if you don't know, how do you manage that if you happen to be on one? So if you don't know, your key account folks can help you, and your co-op folks can help you figure out if you're on a ratcheted demand or not, and what the ratchet might be. So managing demand can provide good cost-benefit results. I find that for a lot of companies that have never looked at managing demand, the payback, the cost-benefit ratio of these types of things is a whole lot better than buying a new energy-efficient equipment. There's a lot of low-cost and no-cost things you can do to manage demand once you know how it's being billed to you, if you've never managed it before. So understand your demand rules and calculations. Do you know the difference between measured and billed demand? We'll talk about that. Measured is what the meter measures, billed is what you're paying for. So if I have a ratcheted demand, my measured demand and what I pay for the month might be different. Do they have a demand ratchet? Do they offer demand control or interruptible programs or other structured incentives where they pay you to reduce demand on a peak day? So what do they offer? What's your strategy to manage and control demand? Trial and error. We just let the employees turn on whatever they want whenever they want to. We have operational policies for employees where we communicate if X is on, Y should never be run simultaneously. Do we have demand lockouts where we take that ability away from them and say, we put a piece of equipment in there so if X is on, Y cannot run? Or do we have it tied to our energy management system where when the demand gets to a certain level, the energy management system automatically goes and shuts other equipment on that's not important, shuts it off. Okay? Those are all strategies people use to save a heck of a bunch of money. SeaWorld. A lot of people are familiar with the SeaWorld parks. They do this bottom one. Cost them about $75,000 to put in a bunch of sensors tied to their energy management system. They save $190,000 a year from reduced demand charges on their electric bill. Do your financial people like you coming to them with ideas that says, we're going to spend $75,000 to save $190,000 a year? Yeah. They're saying, oh, that's one of these really good ones. Yeah. Why didn't we think of that before? Might be the only downside to that. Power factor adjustment. So now at Hoosier, and the co-ops essentially are supplied from Hoosier, it's known as the power factor adjustment. I'm used to calling it power factor penalty in Texas. That's what we call it. If somebody is giving you a penalty on the bill, what does that imply? You know, you're doing something wrong, and if you quit doing something wrong, it might be able to go away. That type of thing. Different states call it different things, but it's basically the same thing. An adjustment applied to the customer's bill if their power factor falls below a predetermined level. And typically that level is 93 to 100% for the power factor for the co-ops and Hoosier system. When I started in the industry, a lot of times those numbers were in the 80 to 85, 89% range. So in my 35 years, the number has been creeping up because power factor is becoming more important. So understand if you're billed on average monthly power factor or peak demand power factor, or if you have a leading or lagging power factor requirement from your co-op. It encourages customers to maintain high power factor. And the idea is we have costs to serve you that go up with a lower power factor as a utility. You can pay us to cover those costs, or you can put in power factor correction capacitors so that we don't have to supply that extra power anymore. You're supplying it yourself locally. So if I have a low power factor and I'm paying a big power factor adjustment, then the next step is I need to analyze if power factor correction capacitors are worthwhile and are a good cost-benefit ratio. So in my example, and most of the Hoosier co-ops do it this way, we're going to have an adjusted demand charge. So there's the demand charge for the 879 kilowatts I was measured for my peak use. Then there's going to be a calculation that's going to add another 258 kW here at the rate for another line item here. And we'll talk about that in a minute. So understand how you might pay power factor adjustment. Is it a line item adjustment? Is it the difference between measured demand and billing demand? And if you look on your bill and measured demand is low and billing demand is higher, that means you have a power factor adjustment there. So if your power requires 97% power factor, so they're not going to ding you above 97%, but if you're below 97%, they're going to make an adjustment. So my billing demand that I pay for is my metered demand, the kilowatts that I set, times 0.97 divided by the power factor at my facility. So 879 times the 0.97, let's say my power factor was 75%. I have a really bad power factor. I divide by the 0.75 and I get 1137 kilowatts of billing demand. So now I set 879, but I'm paying for 1137 with the power factor adjustment. So I have somebody come in, they do a study. They do a power factor correction study. And they say, okay, we think that we can get your power factor to 90% by putting in some correction capacitors. So what does that do for me? The 879 times the 0.97 trigger divided by the 0.9 new power factor means I'm paying for 947 kilowatts of billing demand. So what did I just do? By putting in power factor correction, I drop my monthly billed demand here, if it's always around 879, by 190 kilowatts. At $10 a kilowatt, that's $1,100 or $1,900 basically dollars a month. Is that important when you can show you can do something probably fairly simply and cheaply to drop your bill $1,900 a month in this example? Okay. Now the question we got yesterday, why don't you take it to 100%? Maybe that gets a little expensive with capacitors. There's going to be a sweet spot in there somewhere. The first thing I would look at here is saying, well, I don't need to get it to 100%. I only need to get it to 97% before this thing doesn't affect me. So that becomes, why don't I necessarily want it to get to 100%? In a perfect world, I would probably want to. But I don't need to. I only need to get it to the level where they're going to ding me or above. Sometimes the best cost-benefit ratio is lower than that level. So you have to work with your power factor, people that have done the study, what the costs are, things like that. Then you evaluate the cost-benefit of better power factor correction. Can I target my largest offending motors? Sometimes I've seen plants where it's only 3 or 4 large motors that drag their power factor down. So they can go in and put power factor correction capacitors on that circuit with those 3 or 4 motors, or at the circuit to starter for the 3 to 4 motors. And so as those motors are turned on, the correction is turned on, and when the motors are turned off, the correction is turned off.
Does that change the peak demand whenever you do that?
Yeah. Now, it may not change in my example, where I have the peak demand here at 879, no. But now this number goes down by, 190 kilowatts. Okay. Some companies, and I'm not certain with the Hoosier co-ops, but some companies I deal with, it would just be one line. There wouldn't be no adjustment. And that's what Michelle is saying, yes. It's going to be one line. So it will, when you do that, make your demand charge go down. That makes sense from a plant standpoint. If I know it's only 3 or 4 things that drag it down, put the power factor correction at those 3 or 4 things. Now, in many facilities, it's not just 3 or 4 motors, it's a whole combination of lots of different loads. So then I'm not going to put power factor correction on every circuit in my plant. I'm going to go back to the main service and put in a staged power factor correction device where a controller monitors my power factor and kicks capacitors in and out of the circuit as needed to correct. Okay? So that becomes important in terms of what are we going to do there. So how do I raise power factor? I buy high power factor equipment. How many of you ever have done a spec when you sent a piece of equipment to purchasing to be bought that said the power factor must be above 80% for this 100 horsepower motor we're buying? I see one hand. Yeah, we've done that. I'm starting to see more and more companies now put a power factor spec into purchasing to say, if it doesn't meet this number, we don't want it in our plant. That type of a thing. Okay? So people are attacking it that way. What are the things you want to be careful of when you're buying and putting your plant related to power factor where you can make an oops and drop it way down. Motors, lighting, particularly LEDs, have power factors, and the controls for the motors and lighting. Those are the biggest offenders. I saw a retrofit done in another state here recently where the company got a big LED rebate check from the utility, and then they were screaming because their power factor at their plant went way down. And we started asking questions and looking at specs, and they put in LEDs with a 32% power factor. And those LEDs run all day long, right? So we'll talk more later. You can get some really crappy power factor LEDs out there. They're imported. You can probably guess from where mostly. But that's one thing. How many of us look at power factor when we buy things for the plant? Yeah, we got somebody in here, and the rest of you are going, never heard of people doing that before. 10 years ago, we wouldn't even talked about this. Today, a lot of companies are deciding because of that managing energy, that's something, again, you don't have to buy new equipment, but when you're buying new equipment, just make sure it's going to be higher power factor so you're not getting a bunch of imported junk with a really crappy power factor. Operate your equipment at the correct levels to maintain high power factor. Oversizing motors, particularly that have good power factor at full load, means they can operate at some pretty low power factors. So as I essentially oversize a motor, it will not operate at as good a power factor as it should. So what happens to a plant that has lots of motors? Tim the tool man sized all their motors, more power. They tend to have low power factors. Replace equipment that operates at low power factor with higher power factor equipment, we mentioned that. Or add power factor correction equipment and controls. That's typically power factor correction capacitors, a staged power factor correction system, or static and dynamic VAR compensators we'll talk about in a little bit. So those are our options. What alternate rate billing options are available? That becomes important. Does your power supplier offer any alternate rates and billing options you qualify for? How do you know unless you ask? So that's always one of those, if you have a meeting with your key account manager yearly, that's a great place to say to them, do you have any new rates that we might qualify that might get us lower costs? The answer could be yes, the answer could be no, but at least now you're checking, you're managing. Okay, so that becomes important. Discuss which ones may have the most potential and why, as well as which ones might not even need to be considered. Do they have interruptible programs where you can pay less for your peak demand if you let them interrupt you on peak days? Do they have time of day billing options? Economic demand response? Demand buyback? Do I get a reduction in my rate for having primary service versus secondary service and now owning my transformers? Why would the utility give me a lower rate if I own my own transformers? They don't have to buy, own, operate, and maintain them anymore. That's on me. Might I decide that I can do a better job if I'm a big company of buying transformers and owning and operating and maintaining them? Many companies do. Do they have economic development rates or riders where if you bring in 30 new jobs for 5 years, you're eligible to get a reduced electric rate because of economic development and expanding the job base of the state? All of those are good questions to ask in terms of, are we on the right rate or the best rate for us right now in terms of what you could put us on?